Hello everyone, welcome back to the operating system series. In this video, we are going to learn about the second type of scheduling algorithm, that is shortest job first, and a variation of the same which is also called as shortest job remaining time first. So as you see, we have SJF, wherein it stands for shortest job first, and also there is one more thing called as SRTF, which is called as shortest job remaining time first algorithm or scheduling algorithm. And here, to go understand about what exactly the shortest job first algorithm is, previously when we discussed about FCFS, it was an algorithm wherein whoever came first were given the chance to execute first, no matter what might be the burst time required, all those things. Due to which we had the problem, something called as the convoy effect. We had the problem of convoy effect. To overcome this disadvantage, we have something called as the shortest job first, wherein this works based on the shortest burst time. How? Simple thing. Whichever process has the shortest burst time requirement, they will be allowed to execute first. And in this, yes, shortest job first, the basic initial one is non-preemptive. And when I go with respect to the burst time, shortest job, all those things, it reduces the waiting time of each process. Now, previous algorithm, FCFS, we had convoy effect wherein a shorter burst time process had to wait for more waiting time because of a larger burst time process. That was the problem, due to which I can tell this is a optimal scheduling algorithm that we have considered all these things. So I can easily tell shortest job first is a non-preemptive algorithm, non-preemptive scheduling algorithm, which does the work quickly, which is helping the shortest job process to execute quickly, all those things. With respect to the same, we'll understand the problem, or we'll understand the scheduling algorithm with the help of an example problem. Now here, as told, this is the first example with respect to non-preemptive method, wherein we are considering the same example with 24:3:3. And what I'll do is, we will assume that all of them came at the same time, that is 0 milliseconds. All of them came at the same time. Here, let us understand one more thing. When I was doing FCFS, we were doing writing the Gantt chart first, then we were finding the average waiting time and the average turnaround time. The same thing we will be doing here as well. So, talking about the first step, write the Gantt chart. Now, Gantt chart. How do I write the Gantt chart here? Now, the Gantt chart here is designed in such a way that the shorter burst time process will go first. Shorter burst time process will go first. And here, if you see, P1 is having 24 followed by 3 and 3. So obviously 24 has to wait because P2 and P3 has to complete execution first. And P2 and P3 are having same burst time, so I can take FCFS between those two, and I'll take P2 first. P2 starting at 0 millisecond. Then it completes 100%, that is non-preemptive process, 100% of execution is completed. Then we'll have P3 which comes. P3 was waiting till now, and now P3 starts execution from after third millisecond. So it is 3 plus 3, that is 6. Then at the end comes P1, which is requirement of 24 milliseconds of burst time. Now till the initial 6 milliseconds it was waiting. Now it starts executing. So 24 plus 6 would be 30. So this is what we have with respect to the Gantt chart. With respect to the arrival times, 0 is the arrival time, So that is okay, that is common. Now when the arrival time is 0, we talk about burst time. So it is 24, 3, 3 respectively. Then I'll choose which is the shortest one. Once I am done writing the Gantt chart, we know what is the second step. Second step is finding the average waiting time. Finding the average waiting time. How do I find the average waiting time? Now this is simple here. I have P1 process. How much time did it wait before initially starting the execution? It waited for 6 milliseconds. Then I have P2. P2 waited for 0 milliseconds, as in when it came, it started executing because it was the shortest one. Then I have P3. P3, it waited for 3 milliseconds. So what I can tell is it is 6 plus 0 plus 3 divided by 3. We have only 3 process, so I can tell it is divided by 3. So it is 6 plus 3, 9 divided by 3. It is 3 milliseconds. The answer that we have here is 3 milliseconds. Then the next step that we have. What is the next step? We have third step, that is finding out average turn around time. We call it as TAT, average turnaround time. How do I find it? I just want to know when exactly the process completed the execution 100%, which is inclusive of the waiting time. So I'll take P1. P1, initially it was waiting here, then it completed here. So I have 30 as the waiting time, plus then the second one, I would not write plus here. Second one is P2. P2 is a total turnaround time is 0 plus 3, that is 3 milliseconds. Then I have P3, which is 3 plus 3, 6, that is 3 waiting time and 3 burst time. 3 plus 3, 6. So this is what we have. Now what I'll do, I'll add 30 plus 3 plus 6 divided by 3. What would be the answer here when I divided by 3? So here it is 39 divided by 3, and the average turnaround time is 13 milliseconds. If you see, with respect to the problem, that is SJF non-preemptive method, considering all of the process arrived at the same time, we wrote the Gantt chart. Then with the help of Gantt chart, we also we got the answer for average waiting time, and also we got the answer for average turnaround time also. So this is the first type of algorithm in SJF, that is non-preemptive. Now this is the second example that we are considering, in which we are again discussing about SJF only, but this is a preemptive type of algorithm. So that is the reason we also term it as SRTF. We also term it as SRTF algorithm. What do you mean by SRTF? SRTF is shortest job remaining time first algorithm. Previous one arrived at all of the process arrived at the same time. Now here, when the process arrive at different time intervals, how do we calculate the average waiting time and average turnaround time? This is more essential here. Again, now let us have the Gantt chart. Initially, let us write the Gantt chart. I'll take P1. Why are we considering P1 even if we have other burst time? Because we have to consider the arrival time. At 0th millisecond, I only have process P1. So I have to take 0 millisecond, I have to take P1. Now, this will work for 1 millisecond. Initially I had P1, now I have P2, and P1 has completed 1 millisecond and it is remaining with 5 milliseconds of burst time. Now at this time we have to compare P1 and P2, which is the smallest one. We will compare it and then we'll get to know that P2 is the smallest one. So what I'll do is I'll stop this here for 1 millisecond. This is preempting, and I will take up P2. P2 I will take up. Now I'll again allow 1 more millisecond to execute. At this time P2 is remaining with 2 and I get P3 also. So this time I'll compare P1, P2 and P3, that is 5, 2 and 8 burst time respectively. I'll understand, okay, P2 is still the smallest one, so let us continue with P2. Now 1 more millisecond of execution happens. P2 is remaining with 1 now. P4 comes. Even this is the greater one. So what I'll do is, anyhow, after that we don't have any process coming in. So I'll allow I'll allow P2 to run 100% till the completion. So what I'll do is 100% of completion gets us to 4 here. 3 plus 1 of previous one, that is 4. Now I can tell that P2 execution is complete. I am only remaining with P1, P3 and P4. I have to take P4 because of smaller burst time. I'll take P4. 100% completion will execute. That goes till 8. So P4 is completed. Now the race is between P1 and P3. So again I'll take P1. 5 is remaining. 1 was already done initially, so 5 is remaining. This is 13 and P1 completes. Last one remaining is P3 with 8. So this becomes 21. So if you see, totally the Gantt chart is ready, but due to the preemptive method, P1 is occurring twice. Preemptive method, that is shortest job, P1 is occurring twice. Now, first part is over. This is the first part, writing Gantt chart, done. Now we all know that what is the second part? Second part is finding the waiting time of the process. I'll take P1. P1 has occurred twice. So what we have to do is, initial waiting time I'll take P1, waiting time is 0, plus I'll take the waiting time of second one, that is 8. But the thing is, did it wait for entire 8 minutes? No, it didn't wait, because in between 1 millisecond it was executing. So what I have to do, 8 minus 1 minus 0. What is this 0? 0 is the arrival time. So this becomes 7. Then I have P2. P2 anyhow occurrence is only 1, so it is not a problem. It is 1. But what time did it arrive? It came at first millisecond and started executing that time only. So it is 1 minus arrival time. This 0. P2 waiting time is 0. Then I have P3, which is 13 minus 2, that is 11. And lastly P4. P4 is 4 milliseconds and 3 is the arrival time. So this becomes 1. So overall, if you see, we have 7 plus 0 plus 11 plus 1. 7 plus 0 plus 11 plus 1 divided by total number of process, that is, we have 4 process here. this is divided by 4, so I can tell I have 4.75 milliseconds as the average waiting time. Now, next thing that we know, once the average waiting time is calculated, I have to calculate the turnaround time. I have to calculate the average turnaround time. P1. We know how do I calculate the turnaround time? Waiting time plus burst time. Burst time of P1 is 6 plus I'll just see what is the waiting time, that is 7. So this becomes 13. Then P2. 3 is the burst time, P2, and 0 is the waiting time. So this becomes 3. Then P3. What is the waiting burst time? That is 8 plus what is the waiting time? That is 11. So this is 19. Then I have P4, wherein I can tell burst time is 4 plus waiting time is 1. So this becomes 5. And at the end, we know we have to do the totaling 13 plus 3 plus 19 plus 5 divided by 4. So it is 13 plus 3 plus 19 plus 5. We got 40 divided by 4. That is 10 milliseconds as the turnaround time of this particular problem. So with respect to shortest job remaining time problem, you can see we have different arrival time for each process. We calculated we wrote the Gantt chart first. We calculated the average waiting time, that is 4.75 milliseconds we got, and also we calculated the average turnaround time, 10 milliseconds. We got 10 milliseconds of the same. So with respect to the overall video, we understood how a shortest job first problem works. We understood how the shortest job remaining time problem works, how the preemption is being made, what is the difference between preemptive process and non-preemptive process, all those things.